Dear viewers, uh, today's that is the power system protection and switchgear subject. We are going to cover the topic for universal relay torque equation. So this is that the universal relay torque equation uh, and depends upon that the time slot. So apart from these, what are the other topics? RX diagram of the relay. So today we are going to see that the universal relay torque equation. This part we are going to see. Next one is RX diagram. These two topic we are going to cover on this video, right? So this is the universal relay torque equation. So this is that the universal relay torque equation. So the this torque equation contains the different quantity. So any relay, that is any relay which may going to operate for any relay we need to operate, that is the operating force, that is operating or operating force. So next one is that is the restraining operating quantity, and a restraining force or restraining quantity. So this is that the different combination of that the relay. So this equation which may contains, this is the torque, this is the torque of that equation. So this is the torque which is produced by the current coil. This is the current coil. Okay, this deflection, that is force, is developed by the current. Again, this is developed by that voltage coil. Okay, this is developed by the voltage coil. So here that is K, and this K1 and K2 are constants. Okay, this is the constant. Again, that is this is the during the directional operation we are utilizing this part. So we are going to see on later. So this is the spring constant, that is we are going to spring constant of that relay. So this is in the overcurrent relay. So this is the overcurrent relay. I is the actuating quantity. What quantity? That is quantity, actuating quantity. And the voltage part we are using as a restraining quantity. Again, the spring constant which may be used, right? This is that the so the torque of the relay which may be going to function of that the voltage, current, and the voltage constant, current constant, and we can consider the spring constant also, right? Here suppose if we are going to put the minus sign, so here as like this is the minus sign, right? As like this term will be act as a restraining torque, and this torque due dropping the for neglecting the spring constant. Here that is neglecting, here that is the, this is the point which may be going to consider as the neglecting the spring constant. Okay, so this is the main part we are going to consider for that the what I am saying. So that is the spring constant. The next thing we are going to consider the torque K1 in I square and K2. So this is the two things we have going to consider for the torque equation, right? So next further, that is the major point here. What is K3 VI cos theta minus tau? That is that the thing, the angle between the voltage and the current. This is the angle between the voltage and the current which the relay develops the maximum torque. So for what time the relay will be develop the maximum torque? This is that the voltage at that point. Again, that is the current which may be at the angle of theta. This is the angle of theta, the current which may be going to give. So for what conditions we are going to get the current is the maximum? Normally we are well known, that is cos, that is cos of 0 and sine of 90. So which is we have going to be considered. Sin 90 which is equal to, we are well known, the 1. Similarly cos of 0. So depends upon that the 90 degree minus tau, we are going to obtain the maximum torque. So this is the voltage and the curve. Again we are going to projecting this V. This voltage which can be produced the flux of phi of V, and this is the current, which may be produced the flux of that phi. So this is the maximum torque we have going to consider for the 90 degree. This is in the this direction. So this part is a operating region, this is that the non-operating region. Okay, because whenever that is up to that 90 degree, we are going to consider as the maximum torque. This is the maximum torque. Okay, sine of 90. So before below that 90, it can be deviated from the another quadrant. Please see. So this is that the quadrant we have considered. So this is one quadrant, this is the another quadrant, this is the another quadrant, this is the another quadrant. So for that purpose, that is the this operation which can be shifted from that another quadrant. At the same time, so what is the flux which can be deviated at the angle of phi of V, we are going to project it at the 180 degree, that is in the back side. So again the operating torque, this is the operating torque region, this is the non-operating region. Okay, so then the relay which may be the torque equation will be produced. This is the constant, already we are well known, voltage and current cos of theta, this is the theta value, minus tau. We are what is the maximum torque we are going to obtain. So this entire equation which may be considered as the torque equation, right? So this is the maximum torque obtained, how we are going to obtain the maximum torque of the system, right? So next one is we are going to see that is the operating characteristics of that the relay. Normally the relay which can be going to consider, so this is the R, value, which means resistance. This is the reactance value. So this is also named as that RX diagram. Okay, so RX diagram. So how, suppose if you are having that the transmission line, so this is one bus. Again I am also going to put this is a sending end, this is that the receiving end. Each line having that some impedance, so R plus J of X. Okay, so this R quantity and Jx quantity, which means that Z value is less than this boundary, for example, so this line is assumed as a 7 ohm. So now the Z is equal to 5, it can be lie in this point. So at the same time Z is equal to that is, what is that, is a 10 ohm. So suppose it may be lie in here. So within this region, it may be going to trip by the system. So this is the RX diagram. Which may be a function of this the quantity discussing here, that is the flux quantity is discussing here, right? So this is the point we are going to consider. So suppose this is the line current, that is the positive torque region, this is that the characteristics of an impedance relay, this is that the negative torque region, operating characteristics. If it is increases that time, if the time is increases and the magnitude, if the relay which can be operated in the positive torque region. So similarly here, that is the Z value is lie within this the system which can be in activating, or it can be tripper. Suppose if the fault is, normally the fault impedance is very low, or less than 1, or we have going to 2 ohms at all. So hence we are going to consider that the RX diagram. So this video which is covers the topic of that universal torque equation, which is consists of the operating quantity, that is one of that voltage, and another one is voltage, another one is current, another one is combination of the voltage and the current, which is we are going to attain the maximum torque. This is the spring constant. So these are all the things we have going to attain. The next topic is covered in this video, which is we are going to consider for the RX diagram of that the relay. So this is the normal RX diagram, that is operational thing. So this is the R, that is the resistance, this is the reactance value, again this is the X we are going to operate. So inside the region we are going to take as that the tripping the system. So outside the region we are not going to trip. Suppose that the reactance relay, this is the zero torque position, is at zero torque. So for what positions we are going to take into account. So here you may going to see this relay, the voltage V produce the flux. What is that the flux? That is the maximum torque, and the current we have produced that flux phi of V. Again this phi of V at the range of 180 degree in the opposite direction for that. So in this portion only, for this portion only, we are going to give the tripping zone. Similarly, that is R and X diagram, we are going to provide that the what is the maximum value, that is draw the line. So this part will be do not operate. Again this part only for the operating region. In this operating region, this is the circle, this is the circle. Inside the circle we are going to consider the operation, the outside the circle is not operating. Okay, so this is the point we have considered. So this is nothing but the direction. Okay, directional relay quantity. So this direction, is not be considered, only consider for the this direction. Okay, do not operate that the zone here, that is the operating that the zone. So this operation we are see on the directional or current relay. Okay, right. So up to this the two topic has been covered in this, the RX diagram and the universal torque equation of that the relay system. This is the system.